Hello students, this is Dr. Vivek Roya, Mathematics Mentor, and today in chapter number 1, Real Numbers, we are going to start decimal expansion of rational numbers. As earlier in the lecture number 1, we studied about the real numbers, that is, real numbers is a combination of two numbers, that is the rational numbers and irrational numbers. And also about the rational numbers, we define that those numbers whose decimal expansion is terminating or non-terminating recurring. So here we in this lecture we just want to find out the decimal expansion of rational numbers without any long division. That is which concept we just apply to understand, that is which rational number will be terminated and which will be non-terminated and repeated. Okay, so let's see. So the decimal expansion of rational numbers, as we know that the decimal expansion of rational numbers is terminating or non-terminating but repeating. So we know that any rational number which is in the form of p by q, either it will be terminated or non-terminated. It will be terminated or non-terminated repeated. Non-terminate and repeated. So without any long division, how we recognize that is it would any given rational number or whose decimal expansion is terminated or non-terminated. Okay, so for that we just concentrate on the denominator q. If q is in the form of 2 raised to the power m, 5 raised to the power m, then the decimal expansion will be terminated. Or if q not in the form of 2 raised to the power n or 5 raised to the power m, then the decimal expansion is non-terminated and repeated. Okay, so here we discuss about that by taking some example. So let's see. Here the first one is 3.5, 7.272727 up to so on, and 3.14857142857 up to so on. Okay, so in all the example 25, so in all the example we can see that some are terminated and some are non-terminated but repeated. Okay, so now the first we discuss about the terminated decimal expansion. Now as first example we have taken 3.5. So we know that 3.5 we can write down as 35 over 10. Okay, or 35 over 10 we can write in the form of 2 multiplied by 5. Okay, so this is we have write down the decimal expansion in the form of p by q. So in this example we see that q is in the form of 2 into 5. Okay, next one 47.1245. also it can be written in the form of 471245. when we remove the decimals, then it will be divided by 10,000. Okay, so also it can be written as 471245, and 10,000 can be written in the form of 2 raised to the power 4 into 5 raised to the power 4. Okay, pattern you have to note, that is denominator q, which pattern is taking. Okay, so the denominator q is in the pattern of 2 multiplied by 5, 2 raised to the power 4 multiplied by 5 raised to the power 4. Also the next example 0.222. okay, in this example it will be 222 divided by 1000, and also 1000 can be written in the form of 2 raised to the power 3 into 5 raised to the power 3. Okay, so now we conclude by all the example that a decimal expansion which will be terminated can be expressed in the form of a decimal expansion which is terminated or which is expressed in the form of p by q, then the prime factorization of q will be in the form of 2 raised to the power n 5 raised to the power m, or you can write down 2 raised to the power m into 5 raised to the power m. That is, what is the meaning of that statement? That is, we have to given a decimal expansion. What we are doing, we are firstly express this decimal expansion into the form of p by q. Okay, and here also we have some of the important property with this statement, that is p and q are co-prime. P and q are co-prime. As in this example, we can see that 35 cancel out by 5 7 times. Okay, so it will be, I think, convert into the form of 7 over 2 into 5 raised to the power 0. Okay, so the first condition is p and q are co-prime, and the second one is, that is, n and m are non-zero integers. Non-zero integers. Okay, so m and n are non-zero integers and p and q are co-prime. So according to that statement, if we have to given any decimal expansion which is terminated, the first decimal expansion we have to given, and which type of decimal expansion we have to given, terminated. Okay, and we can express in the form of p by q, and if q is in the form of 2 raised to the power n, then q will be in the form of 2 raised to the power n 5 raised to the power m. Okay, so a terminated decimal expansion denominator can be expressed in the form of 2 raised to the power n 5 raised to the power m. Okay, so this is we have to clear now. The next one, the first question we have to given, that is without actually performing the long division. So here we do not have to be required to perform the long division. Okay, we have to statement whether the following rational number are terminating decimal expansion or a non-terminating repeating decimal expansion. So the first question we have to given, that is 13 over 3125. So 13 over 3125, we can write down 13 over 3125. If we will prime factorization, then it will be 5 raised to the power 5. So finally we can write down that it can be written as 13 over 5 raised to the power 5 into 2 raised to the power 0. Okay, so we check that the denominator is in the form of 2 raised to the power n 5 raised to the power m, where n and m are non-negative integer. So 13 over 3125 has a terminating decimal expansion. So this is a terminating decimal expansion. How we conclude that? Because presently we just write down a statement, that is a decimal expansion which we can express in the form of p by q. If q is in the form of 2 raised to the power n and 5 raised to the power m, then it has terminated decimal expansion. Okay, the next one, 17 over 8, and 17 over 8 can be written as 17 over 2 raised to the power q. Also we can write down it 17 over 2 raised to the power 3 into 5 raised to the power 0. So also we can see that in this rational number p by q, the q, that is the denominator, also in the form of 2 raised to the power n 5 raised to the power n. So 17 over 8 has a terminating decimal expansion. So by this by this question number 1, the part 1 and part 2, you understand that if we have to given p by q, then how we will recognize that it is terminating decimal expansion. Okay, more examples we can do. Then third part is 15 over 1600. So it can be cancelled out by 5 3 times, and this is 320 times. So it will be 3 over 320 and again 3 over. The prime factorization of 320 will be 2 raised to the power 6 into 5 raised to the power 1. So we can see that also here the denominator in the form of, first what we will do, first we have done uh, that is p by q. Firstly we cancel out and convert in the form of co-prime, that is p and q are co-prime. Okay, that is their highest common factor will be equal to 1. So we can see that here p is 3 and q have to given 320. So the highest common factor of p and q is equal to 1. So they are co-prime. Okay, so now we check the first condition, that is they are co-prime. The second we check, that is the denominator in the form of 2 raised to the power n, 5 raised to the power m. So the given p by q form or a given rational number has a terminating decimal expansion. Okay, so next the fourth part, 77 upon 210, and when we can solve it, so it will be just convert in the form of 11 over 30 when we will divide by 7 both of them. Okay, and 11 over 30 can be written as 2 into 3 into 5. So here we can see that the p by q satisfy the first condition, that is they are co-prime, that is HCF of p and q is equal to 1. But q is not in the form of 2 raised to the power n, 5 raised to the power m, because in the denominator one of the number 3 is extra. Okay, which is not in the format of 2 raised to the power n, 5 raised to the power n. Okay, so here we can see that denominator is not in the form of 2 raised to the power n, 5 raised to the power m. So we can say that this rational number 77 over 210 has non-terminating repeating decimal expansion. This is non-terminating and repeating decimal expansion. Okay, so I think we understand this concept here. The next one, fifth part, 64 upon 455, and it can be written as, if we will just do the prime factorization of 455, then it will be 5 7 13. Okay, so it can be written in the form of 5 into 7 into 13. So also we can see that the denominator is in the form of 5 into 7 into 13, which is not equal to the format of 2 raised to the power n, 5 raised to the power m. So also we can say that this rational number has non-terminating repeating decimal expansion. Okay, the next sixth part is, we can easily see that the denominator is in the form of 2 raised to the power n, 5 raised to the power m. So this has the terminating decimal expansion. Okay, so the next one, question number 2. Now, which have terminated decimal expansion and which have non-terminating and repeating decimal expansion? So here in the question number 2, we have to write down the decimal expansion of the given rational numbers. Okay, so let's see the first rational number, 13 over 3125. So firstly we know that it can be written in the form of 13 over 5 raised to the power 5. Now 13 over 5 raised to the power 5, and we want to write down the decimal expansion of the given p by q form. So our target to change q in the form of 10 raised to the power n. that is the exponent of 10. If we will change the q in the form of exponent of 10 or the multiple of 10, then it can be easily convert in the decimal expansion, otherwise not. Okay, otherwise again you have to do the long division method and it will be very typical process. Okay, so the best method is change the denominator in the form of 10 raised to the power n. Now the question is that how we can change in the form of 10 raised to the power n. Now you can also see that 10 raised to the power n can be written as 2 raised to the power n into 5 raised to the power n. I think this is clear. So here you can check in the denominator we have to given 5 raised to the power 5. What we have to given? 5 raised to the power 5. Now I want to change it into the form of 10 raised to the power n. So how it will be changed? Simply I will multiply by 2 with the same exponent. Why with the same exponent? Because when we will multiply with the same exponent, then it will be convert in the form of exponent of 10, that is 10 raised to the power 5. So that's why we multiply numerator and denominator by 2 raised to the power 5. So it will be 13 into 2 raised to the power 5 over 5 raised to the power 5 into 2 raised to the power 5. Okay, so first you understand this concept, that is how we change a rational number into a terminating decimal expansion. Okay, this is firstly you should know. I think you should understand all the concept. Okay, so now 13 into 2 raised to the power 5, so it will be 416 and divided by 10 raised to the power 5. Okay, so now the decimal expansion will be, we start from here 1, 2, 3, 4, 5. So it will be 0.00416. This is the terminating decimal expansion we find. Okay, so the technique you understand. Okay, so 13 over 3125 can be written in the form of 0.00416. The next one, 17 over 8. The same process we will do here. 17 over 8 can be written as 17 over 2 raised to the power 3. Again you can see that 2 raised to the power 3 in the denominator. So you have to multiply numerator and denominator by 5 raised to the power 3. Okay, and it will be easily convert into the form of 10 raised to the power 3, and easily we can change it into the terminating decimal expansion, right? So the same process we will do, multiplied by 5 raised to the power 3, then it will be equal to 2125 over 1000, or we can say 10 raised to the power 3, then it will be 2.125. So the decimal expansion of 17 over 8, very easily here we are going to understand, that is how what is the very easy process to find the decimal expansion of a rational number. Okay, so it is 2.125. So 17 over 8 will be equal to 2.125. So I think you understand how we are changing a P by Q form into the terminating decimal expansion. So the next one, 15 over 1600. Okay, so firstly we cancel out and we convert into the form of 3 over 320, and it will be 3 over 2 raised to the power 6 into 5 raised to the power 1. Now here we have to given 2 raised to the power 6 and 5 raised to the power 1. But we want 5 raised to the power 6 because 2 raised to the power 6 already given. Okay, so what we will do? It can be changed 2 raised to the power 6 into 5 raised to the power 6 by multiplying numerator and denominator by 5 raised to the power 5. So we will multiply it 5 raised to the power 5 in the numerator and denominator. Okay, so now it will be changed as 3 into 3125 over 2 raised to the power 6 into 5 raised to the power 6, and it will be 9375 over 10 raised to the power 6. Okay, so it will be 10 raised to the power 6. Now 1, 2, 3, 4, 5, 6. That is, the decimal expansion will be 0.009375. Okay, so you are understanding each and every concept very clearly. Okay, so the next one, so this is equal to 0.009375, and in the next question we have to given 23 over 2 raised to the power 3 into 5 raised to the power 2. Again, the exponent of 2 and exponent of 5 in the denominator are not the same, so we just convert it. Okay, so we will multiply by, so to express it into the form of, so here also we have written that to express it as 10 raised to the power m, we need to multiply it 5 raised to the power 1. Why? Because when we will multiply by 5 raised to the power 1, so both exponent will be same. Okay, so it can be written in the form of 23 multiplied by 5 raised to the power 1, 2 raised to the power 3 into 5 raised to the power 1. So it will be 23 into 5 over 2 raised to the power 3 into 5 raised to the power 3, and finally 23 into 5, it is 115 over 10 raised to the power 3. So the decimal expansion of this rational number will be equal to 0.115. Okay, so we find that the decimal expansion will be 0.115. Okay, so the next question we move, the part number 5, 6 over 15, and it will be 2 over 5. Okay, we cancel out it by 3, so it will be 2 over 5. And now 2 into 2 and 5 into 2. Why we have done? Because the 5 has the exponent 1, but 2 is not in the denominator. So the exponent of 2 is 1. We have to multiply in denominator and numerator. So by 2 we will multiply, then it will be 4 over, I think, 10, and the decimal expansion will be 0.4. Okay, so 6 over 15 will be equal to 0.4. And the next one, 35 over 50, and again it will be just when simplified, then it will be 7 over 10, and the decimal expansion will be 0.7. So here we are going to understand that is how the p by q can be changed into the form of terminating decimal expansion. Okay, so now the last question. What is in the question? The following real numbers have the decimal expansion given below. In each case, decide whether they are rational or not. If they are rational and of the form of p by q, then what can you say about the prime factors of q? Okay, so some of the decimal expansion we have to given. The number 1, we have to given 43.123456789. Here we can see that this is a terminating decimal expansion. Okay, terminating decimal expansion. Okay, the decimal expansion is terminating. So what? It is a rational number. So firstly we define that is it is a rational number because it has a terminating decimal expansion. Okay, also we conclude that the prime factorization of q will be in the form of 2 raised to the power n into 5 raised to the power m. Okay, and the q will be in the form of 2 raised to the power n, 5 raised to the power m. Why? Because this is a terminating decimal expansion we have to given. So first we conclude rational number, second we conclude because this is terminating, so 101% the denominator will be in the form of 2 raised to the power n, 5 raised to the power m. The next one, 0.1201200012000 and up to so on, it is non-terminating form. Okay, so here we can see that it is a non-terminating and non-repeating. You can see that it is not repeating after decimal 120, then 1200, then 12000. Okay, it is not repeating. So it is non-terminating and non-repeating. So that's why when a decimal expansion is non-terminating and non-repeating, then this is called a rational number. So it is not a rational number, it is an irrational number. Okay, so here you understand that is how without any long division we can find the decimal expansion of p by q, or how we change p by q into the form of terminating decimal expansion. Okay, and how we recognize that is which decimal expansion is a rational number, or is a rational number which is terminating decimal expansion or non-terminating repeating decimal expansion, or which decimal expansion is irrational numbers. Okay, so thank you my dear students.